Thanks, everyone. As some of you may know, I was at Duke for a wonderful 16 years, colleagues with the wonderful Rachel and many others. But a few years ago, I'm primarily a computer scientist, and I moved back to Carnegie Mellon, where I did my PhD as well. And we started the Foundations of Cooperative AI Lab. Here you see a picture of us, and I've singled out here in particular Emmanuel and Eamon, who are both here. You can stand up and wave. There they are. Good. And so I'm going to talk a little bit about their work, as well as, in particular, also Casper here in the back, and Emery, also Vojta, who is not in this particular picture. So the idea of this lab is that as AI gets deployed more and more in the world, we would expect those AI systems and algorithms more broadly to be interacting not only more with us, but also more with each other, right? It stands to reason that they'll run into each other in the world more as well. And so we have to think about AI-AI interactions. And when algorithms in general interact with each other, sometimes you get unexpected phenomena, and sometimes those phenomena are not particularly good. Also, as these systems become more capable and more agentic, we would actually think that some of those interactions, in particular the ones that maybe kind of go off the rails, start to look more game theoretic in nature, right? And so maybe they become more like a kind of tragedy of the commons. And so we should think about that. That's the point of our lab. How are we going to think about not going down terrible tragedy of the commons type of dynamics when we think about AI systems interacting with each other? Okay. I have another hat here at Oxford, which is with the Institute for Ethics in AI, where I have a part-time role. And technically, that institute is in philosophy. So while I think it's wonderful that we have we have the economists, we have a whole day pretty much on computer science today, that's wonderful. But I also want to represent philosophy a little bit. And I think that is particularly appropriate in this context, because I'm going to argue that the game theory for AI agents starts to look a little different potentially from the game theory that we normally study. As Nicole said, I don't mean to say that we need a whole new game theory, everything was, no, like the existing framework is still extremely good. But I do think we need to go to like maybe a little bit more obscure or still unknown corners of game theory as it is. So a little bit more philosophy. Johnny mentioned David Lewis yesterday as well. But I think it's a good time for philosophy in AI, and consequently, I would say also in game theory. Good. So let's get started. Let's do an example of these interacting algorithms. What do I mean when things can go off the rails? Here's a nice example. So this was at some point on Amazon. There's this book, and The Making of a Fly, Genetics of Animal Design. I'm sure it's a wonderful book, but for some reason, it was selling here for about $2 million by two different sellers. Sorry, the resolution is a little bit off. What's that? Yeah, you have to look at the shipping fee, very true. And again, I'm sure it's a wonderful book, but there doesn't seem to be any particular reason that it should be selling for that kind of amount. In particular, if you look over here, the used version is quite reasonably priced. So what actually happened here was that both of these sellers here, Profnath and Bordybook, were using algorithmic pricing. And in particular, their algorithms were looking at the price of the competitor. So at some point, somebody figured this out, and the price actually went up quite a bit more. It came up to $24 million. And what was happening was, here was the strategy that the players were using. Profnath, what it would do is it would look at the competitor's price and slightly undercut it, 0.99 something times the competitor's price. Want it to be the cheaper seller. Interestingly, that's not what Bordybook did. Bordybook actually did the opposite and said, I'm going to take my opponent's price and multiply it by 1.27. What was the reasoning? I don't know. Maybe Bordybook wanted to be the higher quality seller, or maybe Bordybook never even had the book and was just planning to, get the markup from the other person. In any case, because the second number is much further away from 1, you can see you're going to get this exponential increase in prices. So it's a funny example. Presumably no harm done, except maybe somebody wanted to buy the book and couldn't afford it. Not too bad. But you could see unexpected stuff might happen, right? Presumably this is not what the sellers had in mind. A little bit more serious example. 2010, the flash crash. Remember this? So there was this sudden drop in the market, Now, sometimes that happens due to fundamental reasons, right? I don't know, war breaks out, something, but that didn't seem to be the case here. Actually, complicated story, what exactly happened, but for now, it suffices to say that a big role here was played by high-frequency traders, HFTs, who are trading algorithmically, right? And the interaction between those algorithms is part of what contributed to this crash. Okay, now market got stopped, eventually everything recovered. So, presumably not too much harm done. Probably some people made a lot of money, some people lost a lot of money. So it's real, but so far, nothing too bad. But I think we should be a little bit concerned about this, right? Increasingly, we're going to see these kind of phenomena. We already hear a lot about algorithmic collusion in price setting, for example. Okay, that's one. What about other domains, right? There are lots of domains you might be worried about. Cybersecurity, cyber warfare, maybe even kinetic warfare. Here's sort of a horrible mock-up. And you already see people doing all these experiments. So here, this is not real, but here is a paper that puts some language models in kind of diplomatic contact with each other, and they're trying to evaluate how often do they go nuclear on each other. Okay, well, fortunately, that's not real yet, but something to think about. Okay, so that's a kind of a broader context. If you're interested in this, with the Cooperative AI Foundation, we recently wrote this report, Multi-Agent Risks from Advanced AI. I think Jeff is maybe going to mention this at some point as well. A little bit more focused here is kind of the vision paper for our lab, which is also called Foundations of Cooperative AI, which is a little bit more in line with what I'll talk about today, which is more the game theory of all of this. And again, an important message here is that AI agents are in some ways unlike us. And I want to illustrate that. Also, many economists here. I don't expect to get through all my slides anyway. And I'd like to keep it interactive. And so I'll do a couple of polls, but also, in general, I want to keep it interactive. So please ask your questions. Here's something I want to ask you about. So actually, in AI, even though, now there's a lot of talk about agentic AI, as Nicole was just talking about. But in AI, we've very long thought about this idea of agents as well. That agents was one way to conceptualize of the field that what we wanted to build was intelligent agents. And assistants in particular were a common example of this, right? And now in some sense we do have those assistants, right? We all have an assistant on our phone of one form or another. I'm going to focus here on Siri, no particular reason. But so in some sense we actually, that vision of AI assistants has become true. But I will also argue maybe not in the way that we most anticipated, and I want to illustrate that with this question that is about to follow. First of all, how many people use Siri? That's my first, that we can just put in Google. AI Overview tells us 500 million users worldwide. In general, you should not trust AI Overview. What's that?
Using Siri once in their lifetime, or how has it been using?
That's a good question. I'm going to assume that it's the number of current users, not necessarily. No, I think people maybe who have an iPhone with Siri on it, something like that. Good question. But let's put aside that detail for what is about to follow.
This number of registered users.
Number of registered users.
85 million in the United States, it's not every day, it's not now, it's not that. If you have an iPhone, you automatically register. Yeah, but I don't do it.
Good. We got interaction, but maybe in a little bit of a side direction here. Anyway, this is what AI Overview says. Now, in general, you shouldn't trust AI Overview. If you follow me on social media, I've been putting lots of examples where AI Overview gives something funny. But my favorite example still is actually Emin's example. This is Emin, my student, who was applying for a visa.
Thank you.
Which, is that outside the room? So Emin was applying for a visa, and there was this question on the visa application. Have you had a medical exam performed by an IRCC authorized panel physician? He's like, oh, what is this? So as we do, Emin just copied the whole question and put it into Google, and AI Overview very helpfully said, yes. Sorry. That wasn't AI Overview speaking. AI Overview said this. Yes, I have had a medical. Okay. So don't, but here I checked the sources. Yes, the precise meaning of the 500 million, I don't know. But let's take that as a given. Now what I want to ask you is to count the number of distinct agents that all of Siri is in some sense. What I mean by all of Siri, all the servers involved, all the software, all the hardware, including your phones. How many Siri agents are there? Is it 500 million, assuming that that statistic is correct? Is it one, like it's one giant agent, all of Siri together is one giant agent? Maybe it's zero, it's not even an agent. Maybe it's some other number, like maybe the number of servers, I don't know what you would, you might, or maybe you would say, I'm gonna ask you to vote, right? So maybe you will say, well, it's not a very well-defined question. I'm also gonna say, well, you're allowed to not be ready to commit to this answer. Okay, let's actually see it by show of hands. Okay, raise your hands for 500 million. Who thinks 500 million agents? Okay, we got a couple people. Who thinks it's one agent, one giant agent? A couple people. Zero. Who thinks zero? Okay, we got a zero up there. Who thinks some other number? Okay, quite a few other numbers. We'll leave that for the coffee break, what the number is. Who thinks the question doesn't even make sense? Okay, quite a few answers. Who's not quite ready to make a choice? Okay. You saw every one of the answers gets a fair number of people. Maybe I left some out this way. The last one seems to, okay. I recently did this at a computer science conference as well. It was very similar that like it's a split, right? And so this illustrates, I think, pretty well that the notion of agent as we usually think about it here is a little bit hard to see exactly where it applies, right? These agents are somewhat, to the extent that they are agents, are somewhat unlike us. And we should think about that as we think about these types of systems. And in particular here, I want to think about it also in terms of how it allows us to get to more cooperative outcomes. Because they can be unlike us. One thing I'll talk about in particular is that in some cases, maybe we have access to their source code, or at least we can run a simulation of the agents. We can also wipe their memories, for example, or spin up multiple copies, right? What does all this mean from a game theoretic perspective? Here's something to think about. Can we simulate our way to cooperation? Papers with Vojta and Kasper. Also here in the bottom, Sami, Eric, are you here? Here's Sami. Okay. So, Sami, if you want to talk like a little bit more econ paper view on this, but please talk to Sami as well. Okay, but here is an example. You may know the trust game, otherwise I'll explain it here. This is sort of a very simplified trust game where player one has two options. Either to give the 5 that player 1 has to player 2, in which case it gets tripled into 15. Okay, maybe it's an investment. Okay, so if player 1 gives to player 2, now player 2 has 15, but no contracts can be written here, and all that's left for player 2 to do is decide, do I just run off with the full 15, or do I give 10 of that to the investor, to player 1? Okay, that's basically the trust game. And the traditional analysis of it would say, well, player 2 here has every incentive to just run off with the money. Player 1 can perfectly well anticipate that, right? So just by backward induction, player 1 is going to just keep all the 5, which is frustrating because everybody would have been better off over here. Okay, well, that's the thing we're used to as game theorists. Of course, in human subject experiments, people actually don't play that way. They do give, and they do give money back. But I'll put that aside for now. What I want to add, and that's why the game tree is off to the side here, is we're going to add another action. Excuse me. And the other action is that player 1 can now also choose to simulate player 2. Okay? Then, if so, player 2, which we'll say is slightly costly, costs 1 to simulate player 2. And then simulated player 2 will be put in the position of having received the money. And we'll see what simulated player 2 does. I'm going to assume here, just to let the game not get too large on the slide, that if player 2 keeps the money in simulation, then player 1 says, well, I'm not giving my real money to player 2. And the game ends here with 4, 0 because player 1 spent the 1 on the simulation. But if simulated player 2 does give back, then I'm going to assume, to keep it on the slide, that player 1 will in fact give the real money to player 2. Right? So I'm assuming that that's happening, so I'm not even writing that as an action. And then player 2 in the real world has to decide what to give back, whether to give back or not. Okay, what's the solution to this game? Well, it's very simple. If you're player 2, if you're being simulated, you want to be very nice and give money back. And when you're in the real world, you want to run off with the money. Okay, well, that's cheating, right? Because then you can distinguish between being in a simulation and not being in a simulation. So really, we should draw it like this, right? These states are, if we're doing it well, then the player 2 cannot distinguish being in a simulation from not being in a simulation. And this in particular turns it into a game of imperfect recall as well here. In fact, one with absent-mindedness, where player 2, in some sense, is playing twice and forgetting about having played before. That's because the first playing was in simulation, and the second one is in the real world. But in some sense, it's the same agent. Okay? This gets us into imperfect recall games.
But should be actually the same at the simulated P2 of going right and left?
Good. Well, so you need a strategy if you're player 2, right? I'll argue we need a behavioral strategy for player 2. So it could be that player 2, as a program, decides to toss coins. And so the realized action might actually be different up here than here. There are different models you could have of this, and they give you somewhat different results. But then, yeah. Does that make sense? Okay. And now we have a game of imperfect recall, and weird things happen in games of imperfect recall. So let's talk a little bit more about that. By the way, this whole idea of being able to tell that you're in a simulation was, of course, the cause of the Volkswagen emissions scandal, where the cars actually would detect whether they were being emissions tested. If so, they would go into full eco mode, but on the highway, no worries. Okay, so you do have to make sure that the information structure is correct. Okay, let's talk about existence. I'll give 2 stories with this little game up here. The first one is forgetful penalty kick. I haven't recently, but I used to play more soccer. Sometimes you take a penalty kick in soccer, basically matching pennies. But here, just to add to it, sometimes, if I took a penalty kick in soccer, I wasn't very well prepared. I'm running up to the ball. I still haven't really decided. But meanwhile, I have to kind of get my body in the good, position to kick left or right. And so I'm running. I'm like, I'm getting ready to have to choose. I'm getting ready to choose to kick to the left. And now here I'm imagining I'm running a little bit further. I'm like, oh wait, what am I deciding again? And I'm deciding again, right? And I don't know if you ever played soccer. Maybe you're a better player. And so I'm actually deciding twice. And so in this game, if I decide inconsistently, at first I was going to go left, and then I was going to go right, it's going to be a mess. I'm just going to kick the ball way over to goal, and I'll miss anyway. The only way that I even have a reasonable shot is that I choose the same thing twice. I was getting ready to shoot to the left, and again I was right, and I actually shot to the left. Okay? If I'm inconsistent, I miss the goal altogether. If I'm consistent, of course, there's still a chance that the goalkeeper jumps in the right direction, and I still don't score a goal. But if everything goes right for me, that I select consistently, and fortunately for me, the goalkeeper goes the other way, then all is good. What do we expect to happen in this game? What do you expect? Equilibrium? No equilibrium? How often am I going to score? A quarter. Who said a quarter?
Somebody.
Yes. Why a quarter? You said a quarter?
Are you allowed to use a mixed strategy?
Very good. Right? Am I allowed to use a mixed strategy as opposed to a behavioral strategy? Okay, so that's the distinction here. If I have to adopt a behavioral strategy, And this is kind of what I was saying, like, oh, I'm in the moment. Oh, man, like, I haven't even thought about it, and I'm trying to do this thing. Then it seems I'm kind of stuck with the behavioral strategy, that every point I have to make a decision, and I could choose half-half. If I choose half-half, I'll be unpredictable, but half the time I'll miss the goal entirely. And so then I'll score 1/4 of the time. Okay. If my strategy is just to go left-left, always left, well, then my opponent, knowing about this, could stop me always. On the other hand, if I know my opponent's strategy, right, the opponent being the goalkeeper, then I should be able to score with probability 1/2, right? Either by left-left or by right-right. I just play the same thing always. So this tells you actually, if we're focusing on behavioral strategies, the minimax theorem is gone, right? The value depends. Now, on the other hand, we could say, well, maybe we can do, yes, Serge.
Can you coordinate with yourself first and second, or you cannot? It doesn't say what the condition of the game is exactly.
Very good.
I thought you were changing in the middle. So
I am deliberately, I want this.
So what is the game exactly? Do I have recall, or I don't?
Okay. I don't have recall, because here, right?
Which means that the fact that you decided left first time, second time you decide you don't know what you have decided the first time.
Well, but I can still have a strategy. I can say, well, my strategy in life for soccer is I always kick left. I always kick left. Once people figure this out, I'm in trouble.
Condition on your first decision.
That's right. I cannot condition on the realization of my first decision.
Exactly.
That's correct. Unless, now one thing, maybe you argue to Vince, like, come on, like, prepare yourself a little bit. In the locker room, toss a coin, and if it lands heads, then prepare yourself to be always left, right? And I make sure that my opponent does not get access to my locker room. Of course, in reality, I'm still going to forget what coin I tossed, but okay, so, but this is the issue, right? So what do you actually expect to happen? Sorry. Right, and of course, the reason that the minimax theorem doesn't hold in behavioral strategies here is that Kuhn's theorem doesn't apply.
It seems like multi-agent form of Zelten should enter here, and they ran into the same problems we dealt with perfection.
Mm-hmm.
So who's the
Good.
player that represents me later on? Is it me or
Very,
agent?
yeah, very good, right? So maybe perfect segue. Here's a different story. Same game. I didn't touch the game. I was lazy. No, but that's the okay. So player one now. Actually, imagine you're player one. You're a malicious AI virus. You've managed to get installed into 2 different places. You can no longer communicate with your other copy. Okay? You're this virus. And the one thing you can do now is to choose to move left, which is one malicious action, or to move right, which is a different malicious action. But now you find out, after having already been installed, you find out there's this antivirus software provider that's going to try to catch you, or programs like you. And now they have a limited budget, so they either can develop a test that would catch left, or a test that could catch right. And this is kind of like the goalkeeper. And now the thing is that if either copy of you is caught, both of your copies will be found out and shut down. Right? You'll be, your type of program will be identified as a malicious one, and you're out. So you don't. So the trick is you want to be consistent with your copy. If you're not consistent with your copy, surely you will be found. And the game is common knowledge, but this is the locker room issue. I'm assuming that it wasn't to the designers, right? The designers of the virus could have secretly tossed a coin and thereby chosen left or right. But I'm assuming they didn't do that. We're in the moment, and so now we're here again. Okay? What does everybody expect to happen? It's a little unclear, right? And there are these subtleties. Okay, good. Imperfect recall, it's weird. Let's go to this one. How many people know the Sleeping Beauty problem? Okay, good number, good number. How many people know absent-minded driver? It is, right? Though there's a little bit more of a history. So, good. Thank you, Paul. So actually, the Sleeping Beauty problem is sort of a derivative of the absent-minded driver problem. But it's interesting what happened, which was that there was this little flurry of game theory papers on the absent-minded driver problem. But since then, the philosophers have picked it up. So with this Alga paper and a lot of subsequent work. So for the people who haven't seen this before, here's the story of the Sleeping Beauty puzzle. We have a participant in a study. We're going to call that participant Sleeping Beauty. And she is going to participate in this experiment, let's say at a medical school, where she gets on Sunday, she comes in for the experiment. She agrees to be in the experiment. She's told all the rules. This is a study with no deception. Everything is trustworthy. And these are the rules. Once she decides and agrees to go into the study, Sunday night, she'll be given some kind of drug that will make her fall asleep. And at that point, the experimenter will toss a coin. It's a fair coin. Everybody agrees on that it's a fair coin. And that will determine in which of two conditions she is placed. If it's heads, then she'll be in condition 1, let's say. And she will be woken up a little bit on Monday. She'll be awake for a little bit, get to look around, then she'll fall asleep again. The drugs will kick in again. She'll be kept asleep all of Tuesday. On the other hand, if it's tails, she'll be in the second condition, where also she will be awoken for a little bit on Monday. Then she'll fall asleep again. But the only difference is with tails, she'll be woken up again on Tuesday. Okay? That's the only difference. So there's Sleeping Beauty. If it's heads, woken up only on Monday, otherwise both days. And the key thing now is it's a game of imperfect recall. All these drugs, and this is commonly known, mess with your ability to form new memories. Okay? So while she will remember the rules throughout, you would think that if it's Tuesday, she would remember having been woken up before. But no, she can't remember. She also doesn't have any way to track time. I guess if it was me, I could, did I grow a beard or something? But let's say Beauty cannot do that either. So all these awakenings are indistinguishable to her. Don't do this at home. Okay. Now imagine you're Sleeping Beauty and you've just been woken up inside the experiment. What now is, and this is actually the way to sort of specify this down to Sleeping Beauty from absent-minded driver, the key thing is there's not even any action to take for Beauty right now. The only question is, what is your subjective probability now that the coin landed heads? Okay? You don't know whether the coin landed heads, because it's in the other room, you can't see it. You don't know whether it's Monday or Tuesday, but what is your probability? 1/3. 1/3, okay? Why? Where?
Yeah, because there are 3 scenarios where I wake up, and only one of them is for heads.
Good. Okay, so 1 out of 3 scenarios is a head scenario. Okay. Anybody have a different answer?
I'd say 1/2.
1/2.
Because being awake doesn't update, the ovation update.
Good, good. So you might say, just to flesh that out, look, what should you believe on Sunday? Before you go to sleep, what do you think is the probability that the coin will land heads? That should clearly be 1/2. Now you woke up. So what? You knew you were going to be woken up, right? If you learn something that you know you were going to learn, you don't update your belief, right? You haven't really learned anything. Okay, makes sense? Okay. Let's take a vote. Who likes, based on what we just heard, who likes 1/2? Okay. Who likes 1/3? Okay, that's pretty split. Huh? Okay, now there you can go, and there's a whole literature on this, on the various kinds of arguments for and against 1/2 and 1/3. And it's not resolved. This is not like the Monty Hall problem where we know what the right answer is. People actually don't agree. Here's kind of a more economic argument. So here's an argument that somebody tried to make against the position of 1/2, where the reasoning is, okay, well, if you, with different probabilities, presumably you're going to make different decisions. If one of those probabilities makes you make bad decisions, that's probably not a very good probability. Arbitrage, exactly. Or a Dutch book. I'm a Dutchman. I like that. So, okay. Thank you, Paul. So we're going to offer Beauty a bet. Now we're going to actually have some actions. Whenever Beauty awakens, we will offer her a bet. Because we always offer it to her, she cannot update her beliefs based on the fact that she's offered a bet. Okay? She has to say yes or no, and then the bet is transacted on her bank account without her getting to look at her bank account. Okay? So here's the bet that's proposed. If you decline it, nothing happens. If you accept it, then if it landed heads, $11 will be added to your bank account. If it landed tails, $10 will be subtracted from your bank account. Okay? Every time you wake up, you're offered this bet. Okay, argument, if you're a halfer, this is so the distinction between 1/2 and 1/3, people who like the 1/2 answer are called halfers. Okay. Halfers will accept this bet because the upside is a little bit larger than the downside. Let's assume risk neutral, right? So halfer Beauty will accept, thirder Beauty won't. But then, actually, this is a pretty bad bet to accept, right? Because, why? Well, if it's tails, you're going to be offered this bet twice, and you're going to accept it twice. You're going to go down by 20. Okay? That makes sense? And now it's not so hard to make a Dutch book out of this by adding another bet, so we can actually, so goes the argument, money pump the halfer Beauty. Okay. It turns out that it's not quite so simple. So you might have, well, actually, let's see. Who is a halfer now? Okay. Good. So all these halfers, are we going to be able to money pump them? I don't know, but some of the halfers at least have argued, no, you cannot money pump us. I'm going to skip over a slide here, and this relates to something called, there's different types of decision theory. There's evidential decision theory and causal decision theory. You may notice in the content, let me not talk about Newcomb's demon for time's sake, but the distinction is roughly as follows. If you're an evidential decision theorist, the way that you make decisions is you say, I'm going to look at every one of my options, and now the option that I choose might tell me something about the way the world is, and I'm going to update my beliefs about the world for that option. Like, if I took that option, what would it tell me about the world? And consequently, what expected utility do I expect to get? And I'm going to pick the one that maximizes that. Whereas causal decision theory just reasons about what you have causal influence over. So let's see what that means. So here's a way that you could think, as a halfer, with evidential decision theory, you can avoid this Dutch book. Okay? Avoid taking that bad bit. You could think as follows. You could say, okay, if it's heads, I really believe it's 1/2 probability that it's heads because I'm a halfer. But if I accept, I will get 11. But if it's tails and I accept, that is extremely good evidence that I will do the same thing on the other day. Because it's me, it's the same. And like my memory is wiped, so surely I'm going to, like whatever decision I make today, I will make on the other day as well. And so I expect to end up with -20 if I accept. If I don't accept, I expect to end up with 0, right? And so I do the calculation in a sense in the right way. This is in contrast to causal decision theory, where you say, look, whatever I do or did maybe yesterday on the other day, I'm not doing that now. I'm making my decision now. It's going to affect only what I do today, right? I'm not causally affecting what I did yesterday for sure, right? And so that's how I should think about it. Now, it turns out you want to match this with thirding and halving in the right way. If you are a thirder, you want to use causal decision theory, or you're going to get Dutch booked. If you're a halfer, you want to use evidential decision theory, or you're going to get Dutch booked. Okay. What?
You should refuse always.
Certainly refuse this bet. Yes, exactly. Yes.
I can also decide with some probability, 1/2,
You could, but there's no particular reason apparently here to do that. There's no, like, every bet is independent of the other bet. Good. Okay, so it turns out that there's a whole literature on how you can generalize both of these frameworks to actually never get Dutch booked, right? As long as you're keeping this consistent, and you can actually bring this quite generally. I'll skip this. I'll talk just to give a hint at computation, right? So interestingly, also, these lead to different game theoretic solution concepts that actually correspond to different complexity classes as well, with a whole bunch of wonderful co-authors, of course, Paul here as well. Also, Brian, I missed dinner yesterday because Brian was defending, and he passed his defense. He is wonderful and is off to do a postdoc with Kostis, so he's in good hands as well. Okay, but just to point back, right, so this whole imperfect recall business is, of course, also very relevant to this setup with the multiple AI viruses that are thinking, like, you know, what I do as one copy of the virus, does it affect what the other copy of the virus does, and so on. Okay, much of this is probably better left for the break. Lots of technical stuff, but also a lot of real philosophy, I would say, as well. Okay, final takeaway since I'm out of time. So again, it's not like we need some whole new game theory. As Nicole already said, game theory is a wonderfully general framework that fits very well for these kind of questions as well. But I do think we need to go to these little bit more obscure corners of game theory, like imperfect recall, which I think hasn't quite received enough attention. And I think there's some newer corners as well. Maybe that's for another day. And not a bad time for some philosophy, certainly if you're working in AI, but through that, I think also for game theory. And I will end there. Thank you.
We have one or two questions. So help me a little bit. I haven't thought about this problem before you showed it, but it seems that whether you choose half or a third depend on what procedure you use for estimation. If you are a frequentist, you would say 1/3.
So yeah, right. So you could do this, for example, I think this is what you're saying, right? Like, let's say Beauty goes to this experiment every week. Maybe she's low on cash or something, and she's allowed to participate every week. Every week, coin gets tossed. End of the year, she looks back. How many of the times I woke up, was it heads? You will get 1/3, right? Is this what you're arguing?
Even simpler than that. If the Sleeping Beauty looks at the game, and she said, "I'm going to be waken up 3 times," right? So what's the likelihood that
Yeah,
but it seems that the Bayesian, if you are a true Bayesian, you would probably say, well, 1/2. But that's is this something related to how you think about statistics? Or
I don't think so. I agree. Like, that's a reaction people often have, right? Because that was sort of a frequentist argument for being a thirder, and earlier we had more of a Bayesian-sounding argument for a halfer. I don't think that's what it genuinely comes down to, but it does illustrate that if you are, in fact, a thirder, right? And I think actually many of the people here would say they're causal decision theorists. Right? That's typically how game theory works. So then this says you better be a thirder. But if you want to be a thirder, you better say what's wrong with the argument for being a halfer. Right? Why should I update my belief? Like, I didn't learn anything. I think you really go into philosophy. Maybe this is for the coffee break or a beer or something later. But honestly, I think this goes like into metaphysics, right? And like, what is an observation? What is a proposition? What are you updating your belief based on? If you're updating based on the idea that somewhere in space-time there is an awakening, then then the halfer argument is correct. I don't think that's what you're updating on. Probably best for the coffee break.
Should I go ahead? Okay. So I'm wondering where the people are in all of this. So these agents are working on behalf of people, presumably. I guess people created them. And so the book example and the stock market crash and so on. So people created these agents in order to do things. And I don't think AI agents have objectives on their own unless they're programmed into them. So I don't think, if we were to think about the Sleeping Beauty thing, if it's an agent and then do they care whether they lost 20? I don't know. So how do you think about the people who in this world that we're entering, and this potential for these AI agents to be competing with each other, et cetera? How do you think about the people in all of that?
Good question, and very broad question. These days I give talks on consciousness and language models and all this stuff, so we can go way in that direction. The simplest answer might be that, well, yes, I think many of these systems are, of course, designed by people, and we would like them to actually follow the objectives that we give them, right? There are interesting questions how we actually do that best, especially as the systems become more general purpose and acting more broadly in the world, where it becomes hard for us to even say what exactly we want them to do. Anyway, for various reasons, they may end up acting as if they're pursuing an objective function. Whether they really have intentions, there's a whole other workshop I went to the other day. But we can go into the philosophy of it. But behaviorally, we can describe them at least as having objectives, pursuing objectives. Not quite yet today. I don't think for today's language models or the quick things you could do to turn those agentic, they will still not really coherently pursue utility function. But there will be pressure, I think, in part from the people, from the companies that release these systems, from the users, for those systems to become more rational, right? If we get to our AI agents that plan our whole evening out and buy the tickets and all this stuff, I would presumably want a more rational agent to act on my behalf. So I think there will be that pressure towards some form of rationality and not doing, I'm maybe happy to give it some budget, but I would like it to spend it well. So that's sort of how I see it. I think at some level there will be one pressure or another for these systems to become more agentic, also in the sense of pursuing some somewhat coherent utility function. And at that point, we can describe them in game theoretic terms. But yes, hopefully we as humans are still in the picture as well. And to what extent we keep control over all this, it's a big question.
You might have thought about it, and I'm just thinking about it now. So, but Zelton, when he did the subgame perfection revisited, he reintroduced everything through the multi-agent form, and that helps a lot because you separate the decision makers with the same incentives as you, but being at different points on the tree. And that would give some discipline to this discussion. Maybe I haven't thought it.
Yeah, there's still, so I think that's good, right? We should think about what are, right? And in particular, for example, the two copies of the AI system, are they the same agent? Are they not the same agent?
You keep saying who's who, I don't know. And you say you, and you is the same, you is different yous, according to Zelton.
That's maybe fair. But even if we sort of, make as many U's as possible, there's still these interesting questions related to, for example, evidential decision theory, right? Like, let's say we have this game, somewhat similar, where this is all one big information set. Now, I wake up and I'm in a state.
Who's I? Which I of you?
Very good. Let's say I is I. Okay, the word I is confusing.
But
I
it
is
has to be
information
specific.
set. Yeah. But let's say I.
This I. Okay.
Yeah, not the information set I, but I.
Yes.
This the present experience something. Is over here. Right? I don't know I'm over here, but turns out that's where I am. Now,
but if you were, think of yourself conditionally, if you were there, that's the I. As an I at this point, what would I do?
So your question reminds me of Phil Rainey's paper, Explicable.
I don't know Rainey's paper.
Created a theory of how you got there, the second person.
I see. You say that will be, yeah.
Happy.